We have a store that receives customer satisfaction ratings from 0 to 100. In the first 10 ratings, the average is 75. What is the value the store can get on the 11th rating and still be able to have an average of 85 for the first 20 ratings? So some students might look at this and go, what? Why are there 20 ratings? I don't see how that fits in. Well, this is actually a classic problem. What's going on is we're going to have from 12 to 20 another 9 ratings plus our 11th that will give that 11th the least possible value. Well, that must correspond to those 12 to 20th ratings be the maximum possible rating value. Only then will 11th be the least one, such that our total average is 85, because no matter what, the sum of all 20 ratings must average 85, which means, have a summation of 85 times 20. So let's set this up. The total score of all 20 ratings is going to be 85, the average, times the count, 20. That's 1,700. Our first 10 scores must have a summation of 75, the average, times 10. Plus our 11th score is an unknown. We'll call that X. And our next 9 scores are an unknown too, except for the fact they must result in a minimum X, which means they must, if possible, be our maximum score of 100. If the maximum is not 100, that means X could be 0, really. So we're going to assume they're 100 for 9 scores. That's a total score of 9 times 100. And now we solve for X in this equation. So I have basically 750 plus X plus 900, the maximum possible score of those last 9, should equal the total of 1,700. I'll solve for X. X plus 1650, well, let's combine like terms first, equals 1,700. X equals 1,700 minus 1650. X equals 50. The least value for that 11th rating, such that we could possibly still get an average of 85 in all 20 ratings, is going to be X equals 50. We'd have to follow that with 9 perfect ratings, of course, but that is the least value. 36. 2 inequalities. Y is less than or equal to negative 15x plus 3,000. Y is less than or equal to 5x. Okay, so we've got a positive and a negatively sloped line. One is y equals 5x, so it's this fairly steep line that goes through the origin. There's a 0 intercept. And the other one starts up at 3,000, some big number up here, say, and comes down even more steeply at a slope of negative 15. Okay? The solution set's going to be less than or equal to both. So I can keep them solid lines because the equal case is included. So less than or equal to both is this shaded region, this quadrant right there. Okay? So we have points A, B in the solution set. What is the maximum possible of B? So what's the maximum Y value of any point that's in the solution set? Well, that maximum point with a maximum Y value, I should say, in the solution set is the intersection of the two graphs. So I basically have to solve this system of two equations and take the Y value of that point. That will be A, comma, B. So let's figure out what that solution point is, A, comma, B. So set the equations equal to each other. Minus 15x plus 3,000, sorry. I'm going to add 15x to both sides. 20x equals 3,000. That means x equals 150. So our A value is the x value of the solution. So A equals 150. Well, if A equals 150, what does Y equal? Y must be less than or equal to 5x, that is 5A, which is 5 times 150, which means Y is less than or equal to 750. This point here, the B value, will be 750 for that point. And that is the maximum y, or p value in this case, we could have in the solution set.